Okay, so we were on the tan chord theorem, if I'm correct. Am I right in that?
Yes, sir.
And then we're looking at a simple application in the tan chord theorem. I mean, if you look at the diagram, we're trying to find x. So in trying to find x, we're going to use a famous tan chord theorem. And we can see that it has to be equal to 45 degrees. To find y, we're going to work backwards. Angle y has to be equal to 60 degrees. So we can see there's a relationship there. And then to find angle z, we're going to use some angles of a triangle. So before I go away very quickly, to find angle z, we can use some angles of a triangle, and that gives us the 75 degrees we're looking for. So that's a very simple application of the tan chord theorem. We go to the next theorem. Two tangents from a common point are equal. So if we look at this, from any point outside the circle, now you know a tangent only touches the circle once. So there's our tangent. So two tangents from a common point till a point of contact would be equal. Looking at another case of the theorem, and we can see that two tangents from a common point are equal. And what you need to be able to see here is, if I quickly go and join the points of contact, we now have an isosceles triangle, which means that that angle should be equal to the angle at T. And the reason would be angles which are opposite the two sides that are equal. So we can say angles opposite equal sides. And then if we move on with this theorem, and I'm going to skip this problem for now because I'm going to come back to it. And we come to the cyclic quad theorems. There are two cyclic quad theorems. And the first one says that the opposite angles of a cyclic quad are supplementary, which basically means that if we look at y plus w, they are equal to 180 degrees. Looking at another case of that, so we have y plus w equal to 180.
So we can't hear you properly, so you're like breaking up too.
Okay, that could be an internet problem again. Can you hear me now?
No.
Clear? Okay, so if we look at the other case.
Oh, yes, sir.
Yes,
Yes, sir.
sir.
Can hear you now, sir.
All right. So in the other diagram there, we have P plus R is equal to 180. So what is a cyclic quad? A cyclic quad is basically the 4 points in the quad touches the circle. So if we got 4 points touching the circle, that makes it a cyclic quad. And if we look at this diagram, 4 points touching the circle, we have a cyclic quad, which means that P plus R has to be 180. And if we look at S and Q, it's 180. And then we move on. And if we want to find angle X, all we have to do is take 180 minus 85. Sorry, that went too quick. We'll need to go back. I'm actually going forward. So in this case here that we've seen, so if I want to find X, all I have to do is take 180 minus 85. And that would give me X. To find Y, I will take 180 minus 110. And if we look at the other diagram, to find angle Q, I can take 180 minus 70. There's our cyclic quad, 4 points touching the circle. So we're going to use the opposite angles of a cyclic quad are supplementary. And then we come to our last theorem I want to touch on, the second theorem on cyclic quads, and that is simply saying that the exterior angle of a cyclic quad, the outside angle, would be equal to the interior. So there's our outside angle at this vertex or this point. So we find the angle opposite that, and the exterior angle is equal to the angle opposite it. So that's our exterior angle theorem, which says clearly the exterior angle of a cyclic quad is equal to the interior opposite angle. And if we look at from the other diagram, angle P opposite this vertex, we go to, sorry, P and P. So we have our exterior angle equal to the interior opposite angle. So that's a quick walk through the theorems. Now, guys, geometry is different. You know, we can go and look at the memo and get the answers. So we need to have a strategy. I want to teach a strategy today and not necessarily just do past paper questions. We'll come to that a little later. So there are keywords. Now I want you to work with me. Is everyone working with me? I want you to turn to a blank page. So when you're going to read the given information, and these are the keywords you're going to see, you need to highlight it and immediately you need to make links. So look, let's look at the first word, the keyword, center. So if you see this word center, what theorems comes to your mind now that we've done a quick walkthrough? When you see the word center, someone tell me.
A diameter, sir.
Okay, somebody said he's thinking of the diameter theorem. So let's quickly draw a spider diagram. What theorem is that?
So it's the one where the opposite angle is 90, sir. I
That's
think
the
it's
angle in
semi-angles.
the circumference. Great, let's quickly write that down.
Yes, sir.
That's called the angle in the circumference. Let's quickly draw a picture of that.
Yes,
What
sir.
will that theorem actually look like? So we're going to have a
Just be a
diameter,
diameter.
and
Yes,
we're going to
sir.
have a right angle. So we're all drawing
Yes,
a
sir.
spider diagram there. But that has to be a diameter, remember that. And I wonder why he thought about that. Because I wrote center. Why did he tell me this theorem? It's because we know the diameter has to pass to the center. Well done.
Center.
Center.
Right, another one.
Then you said
What's another theorem that will come to your mind if you see the word center?
Angle at center equals 2 times angle at circum.
Well done. So you're thinking angle at the center, immediately angle at the center. So let's quickly draw a diagram there. And what will that look like?
This on the center, and then yeah, like that.
Okay, so we're going to have 2 strokes here because angle at the center is twice the angle at the circumference. So see, one keyword is going to bring into memory a lot of theorems. Give me another theorem that should be coming to your brain. Come on, guys, that brain is powerful. Let's use it. Nobody?
Line from center perpendicular to the chord.
Thank you. So we have another theorem. The chord theorems, okay? So we're thinking line
Yes, sir.
from the center. And he said perpendicular to the chord. So we're going to use what he said first, all right? So let's get quickly a picture of that. There's a center. There's the chord. So what is our conclusion in this one? So it means that that has to be equal to, in other words,
right hand, sir.
midpoint. Can I have another theorem? We need to go a little faster.
So angles in same segment.
But I won't deal with the center. Go down to the center.
Angles in the same segment.
I think that's it, sir.
Sorry?
I think that's it, sir.
No, you're wrong. We think of the converse of this. Line from the center to the midpoint.
Oh, you see.
To the midpoint. Can you turn your mics off until you're speaking? And then we look at the converse of that, which now saying we're drawing from the center, we're drawing it to the midpoint. And what would be our conclusion? The conclusion would be that it is perpendicular. One more theorem I'm looking for before I move on. Can someone tell me that?
The radii.
Yes, that the radius is perpendicular to a tangent. And why did I say that is associated with the center? Because we know that a radius has to come from the center. So from the center to the radius, it is perpendicular. So that's another theorem. Can you see one keyword center? And you should be thinking 5 theorems. Are you drawing your spider diagrams or you watching me now? Hello, are you guys still with me?
Yes, sir. I'm just showing the
reason.
reason, sir.
Okay. So you see how important this keyword is center. Now let's go on
Yes,
to the
sir.
next keyword, tangent. Right. Let's go for it, guys. You see the word tangent. What's coming to your brain?
Tan chord, sir.
Okay, immediately somebody's saying tan chord. So what would that look like? Let's quickly get a picture of that. We got a
Probably just a
tangent,
circle and triangle with the line going across.
got a chord. Can everyone see that? Which means that this angle there, whatever we're going to call it, that's fine, should be equal to the angle. So there's our tan chord theorem. Another theorem that should be coming to your mind. Nobody? Somebody?
Exterior angle of cyclic quad, sir.
It's got nothing to do with the tangent. Must come from the keyword tangent.
Oh, yes, sir.
Same theorem as before, right? The radius is perpendicular to what? A tangent. Anything else from tangent? I'm looking for one.
Tangents from same point.
Thank you. 2 tangents from a common point. You want to get a picture. So 2 tangents from a common. Okay, so here's our keyword called tangent. We picked up 3 theorems from that keyword. Let's move on to another word. Okay, if we see the word diameter, what theorems? Okay, the diameter we would skip. It's the same thing as your center. So we could go back and say,
Yes,
whenever
sir.
you see the word diameter, all right, we covered that. There's our diameter. But remember also,
Yes, sir.
if it says diameter, if we are saying a radius is perpendicular to tangent, it'll also work for the diameter. Diameter, because a radius is half the diameter. So the diameter is also perpendicular to tangent. So I think we covered with that one. Are you all happy with that?
Sir, sir. Sir, sir.
So what about the semicircle one, sir?
Sir.
Oh, yes, that's what the one we haven't covered. Thank you. So let's go and do the diameter. The one we haven't covered before is angle in the semicircle. We all got that? Okay,
Yes, sir.
there goes your diameter, and then we can use the other ones that we referenced earlier.
Sir, sir.
Yes.
So when they give us a diameter, so we immediately know that there's a center. And if they give us a center, we immediately know that there's a diameter.
Yeah, if they tell you that this is the diameter, it means it passes to the center, okay? We don't know where the center
Oh,
is.
so there is a center.
Sorry?
Also, as soon as they say diameter, so there is a center in between of the two
Yes.
radius.
The center will be halfway.
Okay.
Okay.
Yes, sir. Okay, thank you.
And then if we see the word chord and center, if you see the word chord and center, you got to think about the 2 chord theorems, which we covered. Does that make sense to you?
Yes, sir.
So you can do that a little later and take the 2 theorems that we produced earlier. And then we get to cyclic quad. If you see the word cyclic quad, immediately what are you thinking?
Supplementary angle, sir.
Exterior angle, sir.
Well done. So we see, if we see the word cyclic quad, very good. Somebody said supplementary. So if we draw a circle, or we are saying that if that is x, this angle will be 180 minus x. Would you agree with that? Or we could be saying Got a beautiful cyclic quad looking like this. And we can say that the exterior angle, if that is x, then it's equal to opposite. So this theorem is the exterior angle of a cyclic quad. And this we can just use the reason cyclic quad. We don't have to state the whole thing, all right? They accept that as you're saying cyclic quad. Opposite angles of a cyclic quad are supplementary. So that's a quick walkthrough. We spent some time on the theorems. It's very important because you can't go into past paper questions if you don't have the grounding. Are we all good? Do we all understand the theorems?
Yes, sir.
All right, now we're going to
Yes, sir.
move on.
Yes,
I
sir.
want you now to open the booklet that I put up for you guys. Okay, I'm gonna stop the
Which one's
recording.
that, sir?
Sorry.
Which one's that, sir?